I'm James. I'm a product manager at Google. And what I want to do is kind of run you through a narrative of using Apache Beam and Flink and having the cloud take care of a lot of things for you so you can focus on development and not on all of the things that typically suck around using open source software and trying to get it set up. So very big ecosystem, and just as a preface, there's a lot of slides here. At the very end, I have a link to where the slides are. They're all there just so you have a lot of content to utilize for reference, but I'm going to go through some of these slides pretty quickly because we have a very short amount of time. So very big open source ecosystem, and part of our goal is to allow you to use the power of Google's infrastructure to take advantage of this really large ecosystem and make it work really well together. Typically, using these components can be a real pain. So you often, if you're in the hardware world, have to rack hardware, then you have to configure and tweak these open source bits. You have to productionalize things. Even if you use tweaks and tools or you use newer technologies like Kubernetes, Docker, you're still being really hands-on in many cases, getting things kind of bootstrapped and set up in the first place. Scaling can be really difficult depending on how you architect. We don't want it to be difficult. If you're using a Flink cluster, you should be able to scale that cluster up and down anytime, and it should work very, very gracefully for you. Additionally, if you're looking at utilization, trying to plan out utilization can be very, very difficult, and capacity planning can be very difficult. We want to remove that barrier altogether. So if you need to think about utilization, you can isolate your resources so you're only actually, and this is sort of the core value of a lot of cloud economics, so you're only using those resources when you need them, and you're only paying for them when you need them. Quite frankly, one of our core principles is if you don't want to use the resources, don't pay us, don't run them. If you don't need them, don't keep them around. It's wasting your money, and we don't want you to waste your money. So often what people do is they adjust their capacity, so they over or under provision, which means their cost curve doesn't actually match what they need at any given point in time. At best, you're over provisioning and wasting money. At worst, you're under provisioning and letting stuff drop on the floor. Obviously, our ideal goal is to try and bring those two curves as closely together so they overlap. So we have a vision for running open source on Google Cloud Platform. This is a really complicated slide. We could spend a really long time on this slide. The salient points on this slide are Google has been involved in releasing a lot of ideas and white papers, and those ideas have influenced a lot of development in the open source community, especially within the Apache ecosystem. In Google Cloud, we have two products that are designed to take these ecosystems and run them. And one of the projects that you're actually, there's a talk even after me, and there was a talk before today as well, focused on Apache Beam. And one of those products, Cloud Dataflow, is really focused on growing that Apache Beam ecosystem. I'll go into Beam in a second, but that becomes salient because you can run Beam pipelines with a Flink runner. With Google Cloud Dataproc, our goal is to allow you to run essentially the entirety of the Apache open source ecosystem that's focused on data and a few bits that hang off of it, like Presto or whatever, in Google Cloud Platform, where you're taking advantage of our hardware and software. I'm just going to give a brief mention of Cloud Dataflow. Cloud Dataflow is built on a whole host of Google technologies that essentially succeeded MapReduce inside of Google. It's founded on a unified batch and streaming model, which the model and SDK are actually now Apache Beam. The programming model, therefore, is open source. So if you're writing Dataflow pipelines, you're now actually writing Beam pipelines. Those pipelines can run on Dataflow. They can also run on Flink or on Spark or whatever. The portability is a very major focus. Dataflow is designed as a AutoAwesome serverless, fully managed solution, and it's designed to have very low or very high scale depending on what you need. And that high scale is very hard to do, and it's designed specifically around high scale for streaming workloads. So this is really founded on most of the technologies that Google is using internally. But Cloud Dataproc is, sorry, my slides got out of order. So Cloud Dataproc is a bit of the opposite. We want to provide a service that can use the Google Cloud infrastructure, but still expose what is effectively a Flink cluster, or a essentially managed Yarn cluster that you can run Flink on top of. And the goal there is to really give a lot of variability to, if you want AutoAwesome services in Google Cloud, you have those in many services like BigQuery or Dataflow, but a lot of customers actually want their own clusters for various reasons, and the whole goal of Cloud Dataproc is to fulfill that need. There's 3 key points that have really sort of underpinned our focus when we've developed Cloud Dataproc. It's fast, and we've designed these clusters to boot in a matter of minutes. So we don't want you paying for resources when your cluster is just spinning up or configuring itself. That's basically just a giant waste of money. We want it to be easy. So we want to provide a set of tools so you can focus on your code and the frameworks you're using and not the infrastructure around your cluster. And we wanted to even go a bit farther than like what a commercial Hadoop distribution does, because in many cases those are actually also complicated, which is often why there's support attached to them, or there's just a lot of documentation that can be very frustrating. They have a lot of bits that need to be wrangled. And we wanted to be cost effective. So we wanted something that was billed by the minute. So if you used 11 minutes of a resource, we charge you for exactly 11 minutes and don't round up or down. The goal is to really have everything be a one-click. And I'll go into a demo in a few moments, but the goal is to really allow you to create these massively large or very small Spark, Hadoop, Flink clusters with essentially the click of a button. So that means that there's a spectrum. You can point, click, and just create a Spark Hadoop cluster and run Flink on it. Additionally, since it's for all intents and purposes a cluster that's running on all of our downstream services, which I'll go into in a minute, you can take this cluster, you can configure it, you can tinker around with it like a traditional Spark and Hadoop cluster if you want to. You can do a lot of really complicated stuff with it. It's really a spectrum, and it's really designed to have that wide flexibility for sort of whatever people need to do with it. The team that develops Cloud Dataproc also develops open source connectors to work with the rest of Google Cloud Platform products. This is really important because we don't try to offload that development to someone else. And we don't just hope that people do it for us. So for instance, our cloud storage connector has been developed in-house. It talks to the One Cloud Storage API. We maintain it, we've developed it, and I'll actually go into why that's important here in a second. Structurally, and this is why I'm going to offer the slides, because we could also talk about like this slide for a good 10, 15 minutes. Architecturally, Cloud Dataproc is built on Google Compute Engine and cloud storage. So we're inheriting all of the features and benefits that those services provide us. And for enterprise customers, there's some important bits there, like audit logging, or at-rest encryption for cloud storage, or customer-supplied encryption keys for cloud storage. So the clusters that we create are founded on these foundational technologies inside of Cloud Platform. When we create a cluster, we have a set of control planes that we install on a cluster. Those control planes allow us to both interact and manage the cluster, but we also have a jobs API. That jobs API allows you, and I'll actually run a job here where I submit a Flink job in a moment, allows you to submit work to a cluster pretty easily. And we also do things like collect logs, notify on failure, send metrics to our stack driver monitoring. We also stream the output of the driver straight to the console or the web browser. We build all of this with Apache BigTop. It's actually very similar to what Amazon is doing now with Elastic MapReduce. So we splice in sometimes backport patches, but it's all BigTop based, so we're building everything that's in BigTop, and sometimes we pull in additional bits that aren't in BigTop. We provision HDFS with the cluster. We typically tell people not to use it. It's there for intermediate operations like shuffle, spill. You can use it if you want to. Cloud Dataproc is designed as an ephemeral solution. So if you're storing long-term data on HDFS, you obviously need to be very careful, because if you delete the cluster, your data is going to go away. You're actually going to get better performance anyways using cloud storage. And cloud storage does things like handle replication for you. It can geographically distribute your data. With something like cloud storage, you're actually abusing the networking layer, which is much faster than the I/O layer for persistent disk. Under the hood, we have a bunch of tools. I'll actually show you 2 of them. All of the tools except a direct SSH connection are built on REST API. So I mentioned the connector bit, and I wanted to talk about why that's important. Of course, I switched my slides. So it's important because we are very focused on not only running open source software like Flink, we're actually really focused on optimizing, making it better, and then obviously contributing that back to the community. So we actually noticed a lot of cloud storage connectors had a very common problem, and this is true of our storage connector and also others. They were actually bounded by the security provider that ships with Java. we swapped out the security provider with one from Google's fork of OpenSSL, and we were able to more than double reads and actually saw like 20% increase in writes. I mean, that's pretty significant. It's something that we're actually creating a white paper on. It's just an example of, we're not really just focused on running the open source ecosystem. We're really, really trying to actually take it up and make it better for everyone. So I'm going to go into a very quick demo of Cloud Dataproc and probably drop this. Okay, so let's exit my presentation here. And if this ends up being too small, please do let me know. So this screen here is obviously contorted because we're working with a giant zoom. But this is the form inside of our web console to create a cluster. And the reason I show this is to try and show how easy it actually is if you actually wanted to get running with Flink today. I've given a name to my cluster. Cloud Dataproc is available in every zone where Compute Engine is offered, which is actually every zone in Google Cloud. Much like a standard yarn-based cluster, you have a concept of a master and worker node. You can specify the configuration of both. We support, in the web UI, all of our standard configurations. We actually also support the Google Cloud semantic of custom VMs. So on the command line, you could actually create a VM with like 6 cores and 80 gigabytes of RAM if that very specifically fit your workload. And that might actually give you much better cost savings. Through the web UI, we don't currently support that yet. We also have 3 kind of availability types. One is just a single node cluster where we combine your master and worker. That's great for development testing if you want to test out maybe a new version of a component and not totally break everything or pay a lot to do it. Standard availability where there's one master, and then high availability, which offers Yarn and HDFS high availability and is backed by Zookeeper. In this case, I'm just going to choose a standard node because I'm not going to do any stream processing. I've configured my machine types here. We're creating kind of just a modest cluster of 100 nodes, and that ends up giving us 1,600 cores and about 4.7 terabytes of memory. There's a lot of advanced kind of options or things that you can toggle here, like networking settings. We version Dataproc, so you can select specific image versions, which are going to give you a bundled set of all of the open source components. Those images are actually updated weekly. The web UI doesn't express that, but if you went and actually looked at the API calls, you'd notice that we're calling everything with a week number. The one thing that I've changed down here is I've added an initialization action, which is essentially a shell script, and it's going to go ahead and install and configure a new version of Flink for me on the cluster. The reason I show that is this goes to the customizability of Dataproc. You can really do anything you want. You can install software. If you want to run things outside of Yarn, you can. That's totally fine. If we click on the command line option, this is what the equivalent command line request looks like. It's expressing everything, including default options, so it's very verbose. The reason I show it is just to show that even though it's very verbose, it's actually still pretty manageable. And we've really tried to put a lot of thought in making our tooling easy to use, so you don't have to spend a lot of time trying to figure out how to actually use it. And that's a pretty short command even to create a 1,600 core cluster. I'm going to go ahead and create the cluster here in the background. You can see I have another cluster that's already to go, and there's a reason for that. My cluster is in the process of provisioning. We'll come back to it. The next thing I'm going to do is actually abuse our Jobs API a little bit, but again, this is just to show that you can actually do a whole lot of interesting things with Dataproc. We try to not to limit you and lock you down too much. We just try to be assistive, I think is the best way to look at it. This is our job submission form. Again, there's an API for this. I'm actually doing something kind of weird. I'm shelling out to Pig to actually run Flink, which kind of makes no sense, but it actually works. And the reason I do it is, A, we're still adding support for Flink in our job types, which is actually coming very, very soon. And it's not available in the web UI, and I wanted to demo in the web UI. The second is just to show you that you can actually, we're not going to like say, no, you can't do that. If you want to do it, we'll let you do it. In this case, I'm going to go ahead and run this job. You also see these properties and labels. When we express jobs, we allow you to add properties and labels. So you can do things like cost accounting if you want to figure out how much certain jobs cost and all of that. You'll actually see the job will start here, and it's going to spool all of the output from Flink directly to the console. So you can actually see this is just a very simple word count on the collected works of William Shakespeare. It's done at this point. because it's not a very hard task. But you can see that we've actually collected the output here. It spooled it to the console, and we didn't have to go and use, that was pretty easy overall. The VM instances in my cluster are all ready to go. So you can see that Cloud Dataproc we've really tried to make it very fast. So you're not paying for this cluster to just like sit around and bootstrap itself. We generally try to give you clusters in 90 seconds or less. That's kind of our internal target. So that's not too bad of a speed for a cluster of that size, I propose. All right. I know how much this demo costs just because I create this 100-node cluster pretty frequently. I often get asked. The run rate is $12.85. It's not too bad if you actually think that's all inclusive. That's the compute, that's the Dataproc premium, that's all of the persistent disk and cloud storage. So if you were to run this for the 10-minute minimum, and this is incurring the 10-minute minimum because I could conceivably go and delete my cluster now. There's a few things that we're adding to Cloud Dataproc, and I call these out because we're focused on enterprise and new use cases. One is restartable jobs, and we added this very specifically for Flink and also admittedly Spark Streaming. If you submit a job through our Jobs API, we'll automatically restart it if it fails. Sometimes streaming jobs can do things like run out of memory, and that's just a transient error. By having restartable jobs, we can just restart your job based on your specifications. We also rolled out support for NVIDIA GPUs. This is, I think, a more forward-looking feature, but there's a lot of possibilities with GPUs. As I described, single node clusters allow you to create just one node clusters for development. We also regionalized our entire stacks. We set up our control plane and everywhere where Cloud Dataproc is available. That gives you network advantages because when you are talking to that one regional endpoint, you're not making round trips to exchange metadata. It also gives you better data locality and regionalization. There's a bunch of architectural concepts here. I'm not going to go through them. These are actually just in the slide deck. If you're curious, you can take a look at them. They kind of give our very high-level canonical view of the world and how we see Dataproc fitting into the rest of Cloud Platform. You could do things if based on that diagram, like using preemptible VMs, which are built on spare Google capacity. You can use these in your clusters. Preemptibles have an 80% reduced cost compared to a normal VM. The trick is that if Google needs that capacity back, they take the VM and they just give you an ACPI signal of 30 seconds. We've designed Dataproc to work gracefully with these. So if you have very compute-intensive workloads, this is a great way to save a lot of money, and Cloud Dataproc will gracefully handle it. As I mentioned, custom VMs. Here's an example workload. We can create a custom VM to match that example workload very nicely and tightly. You can do things like have multiple clusters. So if you have different jobs and you don't want everything on one giant multi-tenant cluster, you don't have to do that because you can have multiple clusters. Likewise, if you want very separate production and development environments, very easy to do because, again, you can create as many clusters, honestly, as you have quota for, which gives you very good isolation. The other thing that is interesting about that is you can also seamlessly upgrade workloads. So if you want to create a new cluster with an upgraded, say, version of Flink on it, you could create a new cluster and slowly canary over to that version using our tags and labels. So you could actually just gracefully drain an old cluster and seamlessly put in a new cluster. In terms of questions and next steps, again, this is actually very small and hard to read, but we have a set of code labs, we have tutorials, we have quick starts. So there's like a good example of both traditional data processing and also using like OpenCV and JNI bindings to do feature extraction, just because to us, that's a really interesting use case of running stuff on Yarn. There's also a lot of ways you can get help. Some are free. Obviously, the last is Google Cloud Support, which is paid. The Cloud Dataproc team is actually really active on Stack Overflow. You could probably meet most of the team just looking at the tag Google Cloud Dataproc. So if you're kind of curious, I always tell people kind of look at the stuff that people are asking about and look at our answers and try and get a sense for sort of how we're trying to both take the product and also respond to customer requests, because if we don't do that well, that is a failing on us. And last, thank you. This is the link to the slide decks, which I think probably they're going to be sent out anyways, but just in case, I wanted to give everybody advanced access. And with that, I am out of time, but I will be at the Google booth for the next few minutes until my flight leaves. So if anybody wants to talk, I'm happy to do it. Thanks.